So apparently, they're making a fourth phase of matter. Yeah, you heard it right. There is a new phase of matter outside of the normal gas, liquid, solid, right? I'm believing. Like, that's probably what they're talking about, gas, liquid, solids. There is apparently what's called a time crystal. They've created a time crystal. Does that mean like we're going to be able to time travel? I don't know, but I found this video. I found it very, very interesting, and we're going to check this out.
We're filming a video about time crystals.
Yes, we are.
This was like a big discovery in 2021.
They found it in 2021?
We came up with a theory for this new phase of matter. Fast forward to 2021. Physicists used one of Google's quantum computers to make a time crystal.
Okay, can we talk about real quick? Oh my God, we just freaking started the video. We're 19 seconds in, and I'm already stopping. This is going to be rough. This is going to take me all night. Okay, guys. Quantum computers. Like, we're not talking about like Ant-Man. You know what I mean? We're not talking about entering the quantum realm and time traveling and all that. Not yet, maybe. Who knows? But what I do know about quantum computers, okay, they don't deal in like bits, like zeros and ones numbers. They deal in qubits. Basically meaning all of the bits, right? All the information stored on anything that we do or save has energy. And you can manipulate that said energy in some capacity, in some way. Boom, way over my head. I have no idea. But that's like very little what I know of quantum computers. And I hope she explains it.
What does that sentence?
Perfect. There you go. There we go. I dragged my editor into the studio to tell him a new phase of matter, time crystals.
I was looking back through some of the big discoveries in physics that happened last year. I don't know how I missed this one.
Holy, hold on.
Have you ever heard of time crystals?
Let's go back.
How I missed this one.
Stanford physicists helped create time crystals. The quantum computing team researchers, including ones from Stanford and Google, have created and observed a new phase of matter popularly known as time crystal.
Have you ever heard of time crystals?
It sounds like something in the Marvel Cinematic Universe.
It does.
It's gonna be.
Crystals
it's gonna be in the Marvel universe.
Doctor Who series, so you're really not far off. Oh. Do you know what a crystal is?
I don't know what defines a crystal.
Give me a crystal.
Rubies.
Ruby. Okay, so I'm looking up this.
What defines a crystal?
Yeah. It's repeating. It looks like tiles. The pattern is repeating, but in 3 dimensions.
That's what they're made of?
This is what diamond looks like. You're looking down at atoms. Carbon, 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 repeating this way. This is what the pattern of table salt looks like. Chlorine, sodium, chlorine, sodium. But the physics definition
so patterns.
Crystal, it has to do with whether the structure is repeating, whether it has a pattern. So you're repeating this way, you're repeating that way, and you're repeating this way. So it's repeating in all dimensions.
Pattern of cells. Got it. Okay.
Yeah, 3 spatial dimensions. But there's a 4th dimension.
Time?
Time. But imagine you're also repeating in your
time
dimension.
Chat, are we entering into 4th dimension?
No one else did either until 2012. This was like a random thought experiment of this guy named Frank Wilczek. Frank Wilczek is a professor at MIT. I met him a couple times while I was there. A year after I graduated. So that's how recent this theory was. Like not the discovery, but the theory was in 2012.
Is Ant-Man onto something?
After I graduated.
4th dimension is consciousness.
For a class
apparently,
in physics.
No. Apparently 4th dimension is time, Schmitty. Okay? They say the 4th dimension is time.
And he was like, so what if there were symmetries not in just spatial dimensions, but in time as well? And what he thought that might look like is that you could conceive of a material that has some kind of state and it repeats back and forth. So just like with
most things, most atoms or whatever have a repeating structure to them.
Instead, you have a material that's in one state and then a different state and then back to the first state. So like you can imagine an object like that, right? Like a metronome.
Crit. 4th dimension is any dimension other than the 3 dimensions. Don't overthink it. You're damn right. You're damn right.
Think of state as like the left orientation.
Never played Overwatch,
or the right orientation. Can you think of anything else?
Like a seesaw.
Yeah, like a seesaa.
Water evaporating, waterfall.
Yeah, like the water.
Chat.
Like a seesaw.
Chat.
Yeah, like a seesaw.
Why the one video or picture of a seesaw had to have caution tape under it? Like there's a freaking crime scene there. Huh? They couldn't pick any other seesaw, right? To show. They had to pick the one just strung up with caution tape like it's a freaking crime scene. Oh my god.
Seesaw.
Water evaporating, waterfall.
Yeah, like the water cycle. The thing about most of those, something powers that. With the metronome, typically there's like a spring. So there's some energy going in and it's using that energy. So what Frank Wilczek was really imagining like a microscopic scale material that has two different states, left to right to left to right. I don't know, up to down or something.
Is there any material example that is in two states like that? It's not something as big as water or as complex as a clock.
Something really small on the atomic scale. Yeah, there's some things, I mean, what they ended up using were atoms that have spin. I didn't want to get into this yet, but now I want to. Do you know what spin even is? Like I started talking about
Yeah, right. I do. Let me take it over for her, okay? Before she gets into it, let me explain what spin is to you guys. Are you ready? Pay attention, because I'm only gonna do this once. And if you blink, you're probably gonna miss it, all right? So I'm gonna explain what spin is. Ready? Ready? Boom. Any questions? I spun. So there it is. Why watch this? Because here's the thing. I found this video and I thought this was really interesting. The fact that time crystals, like, what is that? Are we entering into like time travel? Like, how is that being used? You know what I'm saying? Like the physics and like discoveries of the world just fascinate me. And I found this and I'm like, oh shit, I need to watch it.
Yeah, me neither.
But there's spin. You're welcome, chat.
One of those inherent properties that's so fundamental to a particle, and we can see what it does. It's like, even with mass, it's hard to explain what mass really fundamentally is. We can explain what it does. It pulls other masses toward it. It affects the curvature of space-time. What is mass? And the same is true.
Mass, how heavy something is.
For a lot of particles have properties called spin. Spin is a really special property because it can change and it can flip from up to down. It can actually point in a lot of different directions, but typically when you measure it on the up and down axis, and it will just choose one or the other when you do that. That's a quantum thing. We're not going to get into it, but for simplicity, let's imagine that our particle can only be spin up and spin down. Spin, it looks like this magnetic moment. It looks like this little magnetic field coming from an electric charge going around in a circle. You'd think like maybe it actually is the charged particle spinning, but neutrons, what's the charge of a neutron?
Negative.
Yeah, it's zero. Don't have any charge.
Kidding.
And they have spin. So it's not necessarily
kidding, guys.
It's not as simple as a charge spinning or a charge going around in a circle. It's this intrinsic.
Dude, thank you, man. I appreciate you. Good seeing you.
To describe.
Makes sense.
Okay, cool. So spin, that is something on an atomic scale that can flip back and forth. So that answers your question in a very roundabout way, but I'm glad that we did that because
I'm glad too, because I would hate to go further without.
Yeah. So here's the thing. Spin, basically talking about what makes up the said material or said item. The materials and the neutrons and all of them have a particular pattern that they spin on, they go on. It's like it's specific to that thing, right? Well, apparently what they did with quantum computers, okay, is they kind of harnessed that and they're able to create time crystals. I don't know what time crystals are for.
Okay, so
I'm probably about to say.
2012, Frank Wilczek's idea was imagine that there's this material where you have a state like spin up or spin down and it flips back and forth. Before you see my brain explode trying to finally explain.
Okay, we're not going to go into you trying to sell us money, all right? Get a mattress, guys. Get it from Helix. Blah blah blah. It's the best mattress on the market. There's no other mattress worth it.
I'm about to tell you about the real time crystals that we actually found. Crystals are the repeating in space. Time crystals would be a material that repeats states back and forth in time. That's why he called it a time crystal. Imagine you don't give it any energy. Like a metronome is using the energy you put into it. 2 years later, so in 2014, a paper came out where physicists argued that this is actually impossible because of the second law of thermodynamics. Have you ever heard of that? Over time, like
time travel, right? Like you can't. The entropy in an isolated system always increases. Any isolated system spontaneously evolves towards the thermal equilibrium. State of max. Oh my God, there's so many big words. Jesus. So does this mean we're getting quantum toilets? I would hope so. Crit, think about that epic vampire. Let's go.
Increase. Yeah. Things don't order themselves. The universe tends to go toward chaos. Overall, entropy increases. The gist of that law is that you can't have perpetual motion machines. You can't have a wheel that just spins forever and ever. You can't have...
I bet you could.
See?
You and
I bet
all
you
of
could.
those TikTokers that are trying to make perpetual motion machines. Did you not watch my video on perpetual motion? Essentially what Frank Wilczek thought of was a perpetual motion machine. And so even on a microscopic scale, it's not possible to have something like this. But then fast forward to 2021, physicists used one of Google's quantum computers to make
Time
a
crystalline.
crystal. Okay,
what?
Physicists used one of Google's
Time crystalline is in order to processor. It displays rich phase structure at low temperature. Okay, hold on. What? You can make one in a vacuum though, like space, a black hole.
Have you heard of a quantum computer?
No.
Really?
Yeah.
Oh wow.
Well, they're so
okay.
rare. Who knows them? Who knows about them?
Stuff.
There's like one, right?
Definitely the former.
Yeah, there you go. Here we go.
I've never actually had to explain a quantum computer, so I wasn't ready for this. But the gist of a quantum computer is that with a regular computer, the basic unit, like the basic thing storing your information are bits, ones and zeros. And they store it as like electrical setting. Even this one, even your phone, like all the processing is done with bits. That's why you have to have terabytes, because you have to have trillions and trillions of bits. So that's a typical computer. With a quantum computer, the biggest difference is that the bits are called qubits. Each bit is actually a little quantum system. So that
I heard about this.
Electron or something that is so small it has quantum properties, which means you have to deal with superposition of states and interact.
Okay, so that's the thing. Like you can interact with it. Like it's not just a like a number. You know what I'm saying? Like how a computer reads it. It's actually like a living thing. You know what I mean?
Acting wave functions and tunneling, like quantum tunneling through barriers, you have to deal with that in a quantum computer. But the idea is that if you've got interaction between all your different qubits with each other, you can have many, many different kinds of states with fewer bits.
Right.
That's enough. They're not user friendly.
I still,
like,
I'm gonna look this up. I still am not quite grasping, okay, the term itself of quantum. Is that just like, what's it, quantum definition? Like, what is, okay, quantum? A discrete quantity of energy proportional in magnitude to the frequency of the radiation it represents. A required or allowed amount, especially in the amount of money. Oh, no, that's not it. In physics, a quantum is the minimum amount of any physical entity involved in the interaction. Oh, okay. So quantum is just like quantum realm small. Yeah, so quantum just represents, you know, anything interacting with anything else. Correct? And like what interacts with each other, no matter how small or big it may be. It's just kind of what interacts with one another and how it interacts.
So no quantum computers yet. But in 2021, we used a
Ant-Man should know this.
Google and a bunch of researchers used a quantum computer to make a time crystal. And the quantum computer, or the bits in it, became the time crystal. We're talking about like something happening on a really small microscopic scale. And where can you get one of those that you can easily control? Inside of a quantum computer. That's what the computer's made to do. So you could have these electrons that are pointing spin up and spin down, and you can control whether they're spin up and spin down or whether they're interacting with each other.
The qubits in Google's Sycamore quantum computer are more complicated than just simple individual electron spins, but I simplified and called them spins, so forgive me.
All of this feels a little bit hard to grasp, like why this is important. All that they really did is they used—
Why is it important, lady? Get to it. I need to know this. Are we time traveling?
They set them randomly to states of up and down. So they took all these qubits and put them in a line so that they were close enough, they were closely interacting with each other.
Right.
That's important. And then they made them either spin
Quantum doesn't matter the positive and negative, right? You know what I mean? Like the protons and electrons, you have that like positive, negative charge for them to like interact. Quantum doesn't do that, right? It's all about the spin of how the cell or whatever it may be is giving off its energy, right? That's what I'm gathering. And the quantum computers can manipulate that in many different ways. So it's not just a positive, negative interaction. It can be anything.
Down, up, 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 down, up. So a random configuration. And then they got them to flip. I am not going to be able to do this. Oh my gosh, this is so hard. Yeah, but all at once. They got them to flip
that's gotta be tough.
to down, up, down, 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 up, down, and then back to the original state and back and forth. And back.
Now the real test.
And then
That's
it'll
crazy.
flip back to its original state, almost like it remembered something from the original state, which
Right.
is what's so crazy about these things. It's like there's this inherent memory in the system of
wait
where
a
it was
second.
and where it's going.
So time crystals, okay, so another crazy thing, time crystals return to their original state even if you accidentally rotate them, say 165 degrees, 780, okay? So wait a second, time crystals, remember? Did I hear that right? When she talked about rotating their spin, you know, doing the opposite, you know, the opposite up and down, back and forth that she was showing on her fingers. When you rotate back and forth and change their anatomy, change their makeup, those cells within a time crystal remember the way they were before? She said it's like they remembered. Oh, so it's still obviously beginning stages, but got it. They robustly maintain this memory due to the interaction I mentioned between the qubits. They're stable enough
But
to
I
be
said
considered
that
a phase of...
2014, we
Yeah.
said that physicists wrote a paper saying this was impossible. But what's missing was that they actually sent in laser light, and they like just kind of kept this laser going
Pulse
at
coherent
it.
microwave
It flipped
light,
back
yeah.
and forth.
So it wasn't perpetual motion.
So it wasn't perpetual motion because you had an input of energy. The difference between this time crystal and something like a metronome is that the time crystal didn't absorb any of the energy. So like the laser light is obviously interacting with the time crystal in some way,
Right.
but it's not using any of the energy.
Crazy.
That's the cool part.
Yeah. Does it flip right after the laser leaves, soon after?
You would
So it does
think
its own
that the
thing?
time crystal, this system would flip states with the frequency, with every oscillation of the light, but that's not what happens. It flips every integer multiple of the frequencies.
I actually got this part a little bit wrong. So
Oh.
I said the qubit
Jesus Christ, lady. Here's the thing. I'm getting invested, all right? I'm listening to this. I'm hearing time crystals. I'm hearing all this stuff. And I'm like, okay, this is getting crazy. Like what science is creating and like what we're on the verge of understanding. Actually messed up. Unreal.
are flipping with integer multiples of the frequency of the light, but it's in fact integer multiples of the length of the pulses of the light and has nothing to do with the frequency of the light. So thank you to Jared and
Pulses.
Robert who reviewed
Okay.
this video and caught that error for me.
You know, every two or every four, which would be weird because it'd be like you push a kid on a swing, right? And they go forward and back with every push that you do. Imagine like you push the kid and then it stays over there for 3 more pushes and you have to like go push the kid and it doesn't come back, and then on the 4th time it swings and then it goes up there and stays again. Pushing the kid on the swing and it only comes back every 4 times. Those are the weird things about this time crystal. It doesn't use up any energy and it doesn't heat up the system. The system stays exactly the same temperature, which is very weird. And then the other weird thing is that it doesn't oscillate with the light. It oscillates with an integer multiple of the light. It did break a symmetry of the universe. Have you ever heard of that? I assume not.
Nope.
It's a complicated way of saying that the laws
Symmetry.
of physics will act the same today
Has
as
to be
they
equal.
do tomorrow.
Yep.
If you put a ball on a hill today, it will roll down. And if you put the ball on the hill tomorrow, it won't roll up. It will still roll down. Translate your system through time. It should do exactly the same thing. But if you look at the time crystal, in one moment, it's flipping like this. And in the next moment, it's not doing that. It's flipping back.
Mr. J,
Often
income.
in physics, you come up
Yo, welcome in, Raiders. My name is MrJGilbert. I'm a 5th grade teacher by day, streamer by night. Right now, we are learning about a new phase of matter. Time crystals, you guys. Time crystals. Crystals that remember what's going on. Like, we're on the verge of time travel. I'm just saying that right now. But Cody, what would you have me do with that amazing raid? Hogwarts hat, Batman mask, fake snake around my neck, or hot the boozle? You get to pick. Let me know. Thank you, dude. How the stream go? Tell me everything.
up with a theory, and then it's like 50 to 100 years before you get the thing. But in this case, the idea was conceived in 2012. The theory is only a 10-year-old, and yet we have the discovery already. That's amazing. That never happens in physics. And in fact, in 2015, there were a couple that we thought were time crystals. Like we were close and physicists were like, we found time crystals. And then we were like, oh, they didn't quite satisfy the criteria. They have to be a little more stable. And then fast forward 9 years, you have a quantum computer doing that? That's crazy. And now there have been other time crystals. There's a time crystal made in light. Now I'm gonna I've given you an idea of what a time crystal is. Now I'm just gonna blow that wide open and be like, you don't even need matter.
This sounds like endless opportunities and really cool stuff.
That's awesome.
Is that what it sounds like to physicists as well? Does it sound more?
Maybe. Richard Feynman, are you familiar with his name?
Yes.
He wrote an entire paper that was about imagining a day when quantum computers are used to simulate physics. You have to use quantum systems to simulate the physics and learn something about it, but you are actually doing the physics. And he imagined a day when quantum computers would be used to do something like that. And here we are.
So you wouldn't hit the limits of an application, you would hit the limits of physics.
Exactly. That's
Thank you.
Time crystals.
Well, you could have sat me down and just told me about the 2012 theory, and we could have hung out and talked about that for a little. It would have been fun.
Yeah, it's true.
So, can I get back to my computer now?
Your normal classical computer.
Yes.
Happy physicsing, Levi.
Thank you. That's the first time you directed it to me.
Let's talk about this for a
I like
second.
how you said thank you. Love it.
Okay, she's done. Let's talk about this for a second. Crit, you said it so far has nothing to do with time travel. Absolutely, okay? I understand, I agree with what you're saying, but what she just said there at the end, and so I thought the entire time, okay? With this quantum computer, with us developing or us understanding what time crystals are and how they interact, we have the potential, the way I heard it, right? Correct me if I'm wrong, but the way I heard it, we have the potential to use physics to control situations. Time is one of those elements that we can control. What if down the road we figure out, we continue evolving and expanding on this time crystal thing, right? And get it to where we remember what happened in the past. We remember how things worked in the past and manipulate that energy to go back there, right? Like creating, like wormholes or creating like whatever, like phase jumps type of thing, right? And what if, right? I'm spitballing here, right? I'm on a freaking tangent right now. I mean, I'm not sleeping tonight. I'm going to go down this rabbit hole and look into this. Time travel is an option, right? You got to kind of think about it could be, right? But what if we use time crystals as teleportation? If we can manipulate the physics of items, the physics of things, okay, through a quantum computer, no less, how would we not be able to take said particles, ions, whatever it may be, everything that makes up something, and teleport it to a different place or jump it through a different place? Well, I think we're already, scientists are already trying to do stuff like that now. But imagine we figure out more of this time crystal stuff and we're able to either A, time travel, or B, just teleport to different areas and different locations, and maybe even just across the room, right? Maybe you can only teleport to somewhere you can see. I don't know. But what I was hearing by the quantum computers using these qubits is what they say, and manipulating the energy of them, right? So you're talking about taking all of your particles, taking them apart, and putting them back together somewhere else. Yeah, that's the manipulation of these particles, right? Isn't that what she was kind of saying in the video? Is that they could manipulate these patterns of what they were doing, right? So why couldn't they take those patterns of of whatever it was made, whatever the item was, right, and move it or relocate it? Or I didn't get that from them. Really? I mean, that's the way I'm thinking about it. You didn't get that? Chat, what do you guys think? Did you get that? What are you thinking about time crystals? What are you thinking about the availability, the functionality of time crystals? What is your take on it?